Hi, I have got something cool to show today. Over the past couple of weeks, I've been working on various physics projects, and during my journey, one that I got really into was pendulum simulations. So, let's take a quick demo of the project. As you can see here, the pendulum swings back and forth, and below we have several graphs visualizing different physical properties. On the left side, we have graphs representing the positions of the mass attached to the pendulum. Similarly, on the right, we have graphs specifically showing the potential, kinetic, and total energies. Alongside, real values of positions, kinetic energy, potential energy, and total energy are displayed. Now, let's see some of the interactive features. By right-clicking and dragging the bow, you can change its starting positions. When you release it, it will allow the pendulum to start swinging naturally based on the physics calculations from the new position. You can also see a trace of the pendulum's path, which uses randomly generated colors to make it more visually engaging. If you are interested in checking out the source code, I've uploaded it to GitHub. You'll find the link in the description below, so be sure to check it out. Before we wrap up, let me give you a quick walkthrough of the source code. I apologize in advance as the code isn't fully organized, since this is just the first version, but I hope it will still be helpful. Let's start with the main function. Here we have the update pendulum function where all the physics calculations take place. If the user is currently dragging the bob, we skip the physics calculations and just update the angle based on the mouse positions. Otherwise, the standard physics calculations will be performed to update the pendulum state. Next, we have the manage trace path functions, responsible for managing the trace path of the pendulum. If the pendulum reaches extreme points, or if the trace size exceeds its limit, the points are removed. Here, you can also see the implementations for randomly generating colors for each corresponding point, which adds a colorful effect to the trace path. The update graph function adds values for positions, kinetic energy, and potential energy to a data structure, used for visualization later. After performing some calculations, the values are added to the data container. If the size exceeds a certain threshold, well, the data points are removed to keep the graphs manageable. Now moving on to the render graph functions, this handles the visualizations of the positions graph you saw earlier. The energy graphs are implemented in a similar manner, displaying the potential, kinetic, and total energy over time. Before we finish, let's take a look at the pendulum definitions. It is represented using a struct for the clarity and simplicity. It stores all the relevant informations like its angle, angular velocity, and length. At the end, there is a function for rendering a text label, which is used for displaying labels throughout the graphs. I hope this summarizes the code well. I have a plan to upload the full implementations of the project soon. Please consider subscribing for new cool projects. Till then, take care and thank you for watching. I will see you in the next video.